Okay, so I've got just one slide today, and but before I start, let me just ask if there are any questions or anybody wants to say anything, make any announcements. Nothing? Okay. I think I have one or two announcements. I guess the first announcement is that they've released the Fast.ai version 2 library, much of which is based on the notebooks from this course. So you can start looking into that if you want on their GitHub site. And I think there's something in the discussion forum about it as well. And the second announcement is that there's this new machine learning course called MLcourse.ai that starts on Monday. And I think there's been some talk about it in our Slack, on our Slack group. So if you're thinking about joining that course, you might want to look into that. Okay. I'm going to move to the first slide. And can everybody see that Lesson 10C review? Hello?
Yes, it's the cover slide is showing.
Yes, great. That's what I wanted. Okay, so there's only one other slide. I'm going to go to that now. Just to have a look at what we're going to do. So chapter 10 is a long one. This is the third. Part, the third lecture we're spending on it, and we're still going to have to spend one more. But I think it's really important, this chapter, so it's worth spending this time. So today, I would like to reach back and go through the 04 callbacks notebook, which I've spent a lot of time annotating and refactoring only in a way to make it clearer, not to change its functionality in any way. And then I also looked at the actually, we're not going to go through the foundations one. I should get rid of that. We've already been through that one. But we will go through the 05B early stopping one. I think these are important notebooks to go through, even though they're really kind of difficult. So mainly the 05 callbacks, well, yeah, it's difficult. But hopefully with the way I've annotated the notebook and refactored it, it'll make it somewhat easier for you guys to go through it than it was for me, because I just felt like the way it was coded was with very little documentation, and the coding standards that were followed were not so great, because there were all these cryptic names and so on. So I just changed things in a way that to help understand what's going on in this notebook. So I'm going to move to that notebook 4 now. I'm going to share that, and we can get started. So share. That one. Okay. Can people see that 04 callbacks _ JCat that I'm sharing?
I can't see it.
You can't see it. Okay. And I think I have to move it to the other screen. Again. Okay, how about now?
Now I can see a picture of the universe.
Oh, that's my other monitor. Okay, let me fix this. Stop share. And share. Share. There. Share. And this is what I want to share. Okay, how about now?
Yeah, now we can. I can see the callbacks notebook.
Okay, great. So that's where we're going to start. Okay, so I've refactored this notebook, and we've already been through parts of it. So the first part of it, which has to do with the data bunch class and the learner class, and the fit function that we built, and So I think we've been through this on a previous meeting. So I'm going to start with the adding callbacks part. So callbacks are basically functions. That's what you should remember, that basically a callback is a function, and it can reach back into, and for our purposes, what we're going to use it for is to reach back into this training loop process that we've set up, and we're going to use it to execute some code depending on where we are in the training loop, and so we'll have different callbacks to go to different places in the pipeline, in the any batch training pipeline. So it's basically going to allow us to have a flexible training loop. And so this is what the training loop looks like so far, and we've been through this where we have a one batch function and then a fit function, and the one batch function processes a single batch the standard way. It first runs the model, calculates the loss function, does the back propagation, does the parameter updates, that's this opt.step, then it zeroes out the gradients to prepare for the next batch. And that's just that. So that's the helper function. And then inside, and then fit is basically a wrapper around this function, and it just runs this function for each batch. It runs through all the batches and executes one batch for each batch. So that's all. That's what our training loop looks like now. But we're going to introduce this callback concept so that we can do stuff at any stage in here that we want to, so that at each stage of this process we can maybe execute some code or do something or get some output or look at the state of our training loop. So the first thing that they do is to define this callback class, and we should think of this callback class as a container for a set of, right now, 9 basic callback methods. And each method is associated with a well-defined stage in the training process. And the way it's set up now, all this thing does is each of these functions. So it's a class, and it has these methods. That's what these little functions are inside the class. It's a really simple class. It's just a container for all these methods. And what are these methods? Well, they're just names that have to do with various stages in the training process, and every one of them basically does nothing but return true so far. Okay, and some of them have inputs associated with them, because when you start the fit function, you have to take in the learn object so that it has a learn input. The begin epoch, when you start on an epoch, remember an epoch is one complete run through the training data. When you start on an epoch, you have to know which epoch number it is. So you have this input of epoch that tells you the epoch number that you're starting. When you start a batch, you have to have the batch. So that's what this XB and YB are. They're the batch. And remember, XB is the data for the batch, and YB is the labels for the batch. And then when you do the loss after the loss, for the loss function, you have to know the loss function. So the input is loss. Okay, so that's that class. Then he defines this second class called a callback handler class, and the callback handler class is basically a collection of methods. Again, a method is a function inside of a class. And these methods are, first of all, a bunch of wrapper methods for each of the methods in the callback class that we just looked at. So each one of these methods here, each one of these callback methods is going to have a wrapper, a corresponding wrapper method that does something extra, that takes that method and does something a little extra, or is a little bit flexible in what it does. So, for example, if you look back in the basic callback method, begin fit just takes in the learner object and then it returns true. But the callback handler class the begin fit is going to do a few other things. Okay. And finally, so there's a wrapper method for each of these methods that we defined in the callback class, and then there's a do stop method, which that's the last one here, and it's checking whether some condition has been set so that we should have to stop the loop. So, and then once it checks that, let's see. So it checks whether let's see. It returns the stop. It returns the stop flag if it's been set, and otherwise it sets that stop flag to false. That's what you can read this as doing. Okay. So that's just what this commentary does, is to help us understand what's going on inside of this callback handler. Callback set stop. Yeah. That's what I just said. So then we got these methods then, and you can start looking at what they do. So for example, begin epoch, it trains the model. It sets the in-train flag equals true. It sets the return state to be true, and then it looks at the list of callbacks that were passed in, because that's the other thing is you can, for the callback handler, it takes as an optional input a callback that you could a callback, and we'll see later how that gets used. And then what it says is let's see. Okay, so if there's a callback, then if a callback was passed in, then callbacks is going to be true. So and in that case, it sets the object's callback property to that callback. And why it says callbacks with an S is because this input is a list of callbacks. So it takes as an input a list of callbacks that may have one or more callbacks in it. Okay, so and if it gets that input, if it gets an input list of callbacks, then it sets this dot callbacks, it sets this property to be that list of callbacks. If there's no callback passed in, then self.callbacks would just be empty. Okay, so that's what this initialize method does. Okay, and then okay, so then we talked about the begin fit. That's starting the training loop. And after fit, let's see. I should indicate what this loop does. So every time it executes one of these methods, it's going to loop through all of the callbacks that were added that were in that callback list from the input. And if it finds that callback, that finds this particular callback, so that it finds begin fit among those callbacks, then let's see. Then it's going to return true. So I've set state equals true here, and now state is going to be the and between the current state, between what state is right now, and callback dot begin. So it's going to loop through here, and then if it finds, let's see, state's going to be true if the input list includes callback dot begin fit. In other words, if begin fit is passed in as one of the callbacks in the list. And it does the same loop for every, so it's checking, it's looping through all the callbacks in the list, and if the callback that's associated with this method is present, then it's going to return true. It does that for each one of these callbacks. And then, let's see, I put this question in, but I don't need that question. In the begin validate, self.learn.model eval is basically it's basically running the validation set through the model. And see where it says begin epoch, that's what it does there is it runs the training loop, it runs the training data through the model.
Sorry, Joseph, aren't those just setting flags over there?
They are, but this part though, this part doesn't.
Just go self.learn.model.train, and if you put your cursor in there and just hit Shift Tab, probably.
Yeah, Shift Tab. So I did that. Press the cursor on it and hit Shift Tab. It's not telling me. There's another way to do that, right? You can do, well, if you run learn.model.train, that will actually execute the training loop. And learn.model.eval will execute the validation loop. Because remember, learn.model is the model that you've given it, and the model has these methods, call, eval, and train. And when you want to train, you call the method train. It's in model is what we want. So let's see, is there a, what we could do is we could look at the learner. Let's execute some of this stuff. So let's do this. Here. Okay, well, there's the data bunch. And there's the learner. Trying to see how we can get in here and look at stuff. So we would pass in. Here's where it builds the model, and so we've got the data. Maybe we can just execute this thing off to the side here. And then we can look at the model. So I'm going to just make a little cell here. And get model is going to return a model and an optimizer. And so I'm just going to see what happens there. Okay, now I can have a look at that model. So I'm going to look at the model that we just built, and it has properties and methods. Let's see, it should have an eval method and a train method. So so let's do this. Model.eval. Oops, model.train. Because that, so I claim that when I call model.train, that's actually going to train the model.
So now on that model.train, can you do a Shift Tab?
Yeah. Shift Tab. Model.
Not on the model, inside train, the brackets.
So this one here?
And just inside those parentheses that you have in the end.
Oh, just like that?
Just leave your
Oh,
cursor
just
within.
put the
Yeah.
cursor there and then do a
Yeah.
shift tab?
Yeah.
Okay. Model.train mode equals true.
So when you call model.train, mode is equal to true. So you're basically setting it into a training mode.
Oh, okay, okay. So that's not actually executing the training.
Right. You're not training that as such. Basically, its training mode is telling it not to, rather, when you do eval,
Well, yeah, when you do eval, it's not going to do the backpropagation and so on. Right,
yeah, and the dropouts and all that stuff is not going to be done.
Correct. Okay, so then back in here where we were, I should make a little note that instead of, because I was claiming that it was actually evaluating the model and it's not. So this is our so this is where I made a mistake. All this is doing is setting the next line just sets the model to training mode, where remember, training is different than evaluation. In training, we are we're doing all, we're not only evaluating the model and the loss function, but we're then doing the backpropagation and setting the updates in order for our model to converge. But when we're doing evaluation, all we're doing is running the data through the model and making predictions. That's all we want, and also calculating the loss function to see how good our predictions are. So that's what I mean by training mode and validation mode. So what I should say then, and thank you for pointing this out, because I was under the misunderstanding that actually ran the training. All it does is it sets, so, and then self.learn.model.eval sets the model to validation, where it's just running the validation set through the model. All right. So the next thing he does is he creates this little test callback class, and this is intended to be passed into the callback handler. Remember, the callback handler takes a list of callbacks in it as an input. So this is designed to be an input into the callback handler class. So let's see what it does. First, it initializes begin fit from the callback class. That's what this super.begin fit does. It it refers back to the parent class, which is callback. The parent class is callback, and it initializes begin fit the way it was done in the callback class, so that we didn't have to write it all over again. Then we can set the. I added this line here because I think this is where it needs to be done. The maximum number of iterations we want to go through is 10, and we initialize. So I put that as a hard input, but we could possibly modify it to take that as an input. But right now, I just set that as a hard input. And then I set the max iter to be that. And then I initialize the n iter, which is the number of iterations, to 0. And I have this variable called n epoch float equals 0. I initialize it to 0. And I also initialize the batch counter to 0. The n epoch float is my name for this thing that they're trying to introduce this counter for epochs that actually gives you a non-integer count. So like if you're running through an epoch and you're halfway through it, you can see that you can see that n epochs would be 0.2 or 0.3 or 0.4 depending on how many batches you've processed, and we'll see how that works later. So we're just going to initialize that n epoch counter. So it's not just going to tell us the number of epochs that we're in, but it's going to tell us the fractional epoch as well. And every time you process a batch, you've processed, one fraction of an epoch, and so it's keeping track of that, and we'll see that below. All right. So I think just ignore this comment here. So I looked at this begin fit and noticed that it used the super method to initialize itself from the initial method, from the initial callback method. And then I asked myself, why didn't this after step also use the super method to inherit from the parent class? And when I look back at the parent class, I find that the previous after step in the parent in the callback class doesn't do anything. It really doesn't do anything but return true. Let's go back and look at it. Here's the basic callback class, and after step does nothing but return true, whereas begin fit actually took an input and set self.learn equals learn. So in the test callback class, that's why we didn't have to use the super method to initialize it. So what's going on here? After step, we're going to increment the number of iterations, and then we're going to check it to see if it's exceeded the maximum number of iterations. Remember, we set that to be 10. And if it does, then we set the stop flag, the learn.stop flag, to be true. And then I added this little print statement so that we can see what it's doing. It'll print the n iterations number, the batch number, and the stop flag when we execute it. All right. The next thing he does is to refactor the training loop using the callbacks now. And so here's how it looks. Remember, we had this one batch. So let's look at this. Too bad I can't fit it in the screen because I put so many comments on it. So the first thing that it does is it checks to see whether it should continue. So if not callback begin batch, then it exits. And I put a little statement here so that we can see if it ever exits, we can see why it's exiting. So that, exiting from one batch due to begin batch. That's what this would tell us. If it ever exits due to that condition, we would see it. So the next thing we do is we run, when we're executing a batch, we run the model and compute the loss function for the current batch. And that's all done in this line. See, it's learn.model. That's the line that actually executes the model. You give it the XB is remember XB is the input batch that we got from the data loader. And so callback.learnModel.xb, it runs the model on that batch. And YB is the labels corresponding to that batch. And so this function, learn.loss function. So the loss function, remember, it takes as an input the predictions, and that's what's going to be given by this learn.model of XB. That's going to give you the predictions for that batch. And then the other input is the actual labels for that batch. And so the loss function is then computed with those as an input. So this line does a lot of things. It runs the model, gets the predictions, compares the predictions with the labels, and computes the loss function. Okay, and then I have this this print statement just to help me see what's going on executing on batch. And the next step, remember, after you compute the loss function, is you want to do the back propagation. But let's see. But only if we're in training mode. So, and that's here, I guess. After loss, it would tell you to exit if you're not in training mode. So then, if you're continuing, if you're still in training mode, then you compute the you do the back propagation. And let's see. Oh, actually, yeah, you do the back propagation, and then the next step is you do the updates. That's what this opt.step does. And then the last step, remember, is you have to zero the gradients to prepare for the next batch. Okay, so this one step, one batch is a helper function to process a single batch. And then they created another helper function that processes all the batches using one batch. So all batches takes a data loader and a callback as an input. And it runs through all the batches in the data loader, processing them one at a time. And now, again, there can be a callback involved in the processing. So that's what this callback input is. And then we process the batch. We then check whether to stop or to process the next batch. So after each batch, you do this check. And if the stop flag is set, then you exit out of the batch. You exit out of the batch. All right. And now here, so these two functions, one batch and all batches, are the helper functions that fit is going to use. And that's our training loop, is fit. So here's fit now, using these helper functions and whatever callbacks you give it. And notice I've refactored fit, but all I've done is shifted the n epochs to the right, because remember, then I can supply a keyword. Then it becomes a keyword. I can use it as a keyword input if I want to, and that's more convenient when you call the function. So instead of just calling fit with a number like 5, you can say n epochs equals 5, and then it's easier to understand what you're doing when you're calling that. All right. So what does fit do? It checks whether or not to start the training loop by checking the begin fit callback. And if it's not supposed to start the training loop, then it just exits out of this thing. Then it loops over the specified number of epochs. So it loops over whatever the n epochs input you gave it was. So if you want it to do 5 epochs, then it will loop over. It will do this loop over 5 epochs. It checks whether to process the next batch, and if it does, then it let's see. If not callback begin epoch, then it continues, which means let's see. Then it will. Let's see. I say jump to the next. Yeah, jumps to the next epoch. So continue here will actually exit out of this epoch loop. Sorry, it will move to the next epoch in the epoch loop. So if it doesn't have to do that, then it just does the all batches, which means it processes one batch at a time. The next thing it does is to check whether to process the validation set. So it asks for whether begin validate should be true. And if it is, then it does all batches, and specifically with torch.nograd set, so that it saves a lot of space because it doesn't have to save room for the gradients. Then it checks whether or not to break after the current epoch has been processed. And then it sets the callback state to indicate that that fit has been run. So that's the new fit function using these two helper functions. Remember, fit was, let me go back up to the top here, where he gives us the initial version of the loop, of the training loop. Yeah. Let's see. Sorry, I'm just scrolling here to find the initial version of the fit function. Oh well, I'm not finding it. So anyway, this is the new evolution of the fit function, what we just did, where we've inserted callbacks into it, so that now it's a much more flexible loop. Okay, so now having done this, we can run this loop. Let me start this whole thing again, run all the way down, and run a loop with our new fit function. Do this, and then I'll just execute them one after the other. Down there. Fortunately, this notebook runs very quickly. Uh-oh, model. I think I skipped something. I don't need this. This is just something we were playing with, remember? So I'm going to erase this. And that's the way the notebook was when we started. So again, restart, output, Okay, let's pay attention to this a little bit. It's interesting that when you, so we've built these data loaders. That's the preparing for the mini batch training. We give it a batch size. We specify what n out should be. Remember, n out is the number of classes, the number of digit classes. So in the case of the MNIST data set, there are 10 output classes, one corresponding to each of the digits 0 through 9. So remember, in the original version of this notebook, this was just called C, which I think is a pretty dumb way to do it. You never want to name something with a single letter because then you can't find it. You know, you try to find where it's used. If you search on C, it's just going to hit everywhere. So I called it N out instead of C. Oops, I did something. Okay, so now we build the data using the data bunch class. And remember, we went through this before, the getDLs function, the trainDS, which basically the basic data sets that come in. We specify the batch size, we specify the number of outputs. And what we're looking at here is the size of the training data set, which is 50,000 lines by 784 columns. And remember that 784 columns is just the, I think it's the 28 by 28 images of the digits of that, flattened out, because 28 squared is 784. And then the size of the Y, the shape of the Y, remember Y is the labels, and so for them, we only need one label for each example, so that makes sense. But now this is the thing, so we've seen this before. This is the thing that I thought I wanted you to see. Remember, this data loader is this, it produces these batches for you. And it's an iterator, so that means that every time you call it, it will produce another batch. But the interesting thing is that when you use length on the data loader, it actually goes through and counts the number of batches that it has in it. So when I ask for the length of data.train, when I ask for the length of the train data loader, it gives me 782. That's the number of batches in the training data. And when I ask for the length of the validation data loader, it gives me 79, which is the number of batches of the validation data. And how does that make sense? Well, let's look at this next thing. The length of the train data loader, which is 782, multiplied by the batch size, which is 64, gives me 50,048. And that's the number of batches it would take to get through the training data, right? And when I look at the length of the validation data loader, which we saw was 79, and we multiply that by the batch size, but giving it an extra factor of 2, because remember, the validation data doesn't have to have the gradients with it, and so it doesn't take as much space, and so we can double the batch size. That's what I think that was a comment in the video. So so this helps us to make sense of this number 79, because if you multiply 79 times 2 times 64, you get 10,112, which is the number of which is, so in other words, it takes 79 of these batches to get through all of the validation data. Does that make sense to everybody? Yes, no? Somebody say something?
Yep, that makes
Okay.
sense.
If there's a question, please ask.
I think you can go ahead and even do like data.trainDL dot. I think there's a data set functionality also there, because that's how you built it out. I don't remember what the dot is though. I think it's a dot X or a dot TSX.
I think it has X. No, the train DS has X and Y in it. But this is just to show you. This is just to show you that these that the lengths of these data loaders make sense. In other words, how many batches that each one of them contains makes sense, because that's how many batches it takes. 782 batches to go through all of the training. 782 batches of 64 examples each to go through all of the training examples, 50,000. 79 batches at 128 examples each gets you through all the training, all the validation data. And the thing to point out here is that for the validation data, we were allowed to we doubled the batch size because the memory requirements for the validation data are smaller since we're not carrying along the gradients. Okay, so the next thing, you package up, remember from last time, we package up the everything we need for the to run the model in this item in this learner object. So this thing, start get model data, gets us the model. It outputs the model and the optimizer, and then so the model and the optimizer are inputs, and then the loss function is an input, and the data is an input. So that packages up everything you need to do the training. And then, this is a thing that the gentleman pointed out here. If we, oops, we didn't do that yet. I have to define the model, and I can, yeah. So this just shows us what's inside the model. That it's a linear layer followed by a ReLU followed by another linear layer. We've been through this before. Now we can instantiate a mini batch training loop and start training. That's something we did before. That was with the old fit function, and you can see that we've got a good result after, at least from the training, after one epoch. But now we're going to add the callbacks, and this is I'm going to run all of these functions that we compile all these functions that we just introduced. This is the test callback function. And so this is where we were. We actually got down to here explaining what all this stuff is, the new way to do the training loop. And now we're actually going to do it. So the way we do it this time, the call to fit is the same as before, except we've inserted a callback. And the callback is callback handler with test callback. Remember, the callback handler takes a list of callbacks as an input, and we're going to give it one item in this list. We're going to give it the test callback that we created above. So this is this is the new way to call fit to run the model. And there it is. And it's giving me all the outputs that I asked for. So this isn't, so you can see what it's doing. Each time it executes a batch, it tells us so. It tells us that it's doing parameter update iteration 1 from batch number 0, and the learn.stop is false. And then when it gets to parameter update 10, now remember we told it not to go any farther than 10, so it now tells us that learn.stop has been set to true. But the next thing it does is it starts the begin validate, because we've told it, where did we do this? We did this way back up on top here, the callback, the list of callbacks. We told it that begin validate should be true. So in other words, we've set it, the way it's set by default is that we want to do validation. Okay, so that's why that happened. It finished the training here, and it exited because we did 10 iterations. But then, remember, it checks to see whether we want to do validation, and it will find out that we do because we've got that set. Begin validate was set to true. So it says begin validate is true. And once it does that, it sets the stop flag back to false because it doesn't want to stop. It wants to continue going until there's a reason to stop. So I had a question about that because I noticed that, let's see, I think I asked the question. Yeah, why is the learn.stop still false? Afterwards, after you do this, the learn.stop flag is still false. We saw that the training loop set it to true before it exited, but then what we find out when we do these printouts is that the validation loop set the flag back to false. So that answered my question. I was wondering about that. Anyway, so what does it do? Now we see it executes one batch. and exits. Each time now we're doing validation. So each time it processes a batch, it exits from the after loss part, because after the loss function, you're done if you're doing validation. You don't want to do anything of the back propagation or the parameter updates. So I just made it print out for me the reason why it's exiting from the batch. And you could comment that out if you wanted to. But it's just showing me what's going on. And then if you count all of these, how many do you expect before it stops? Well, you expect however many batches there are in the validation set. And we found out that there are 79 batches. And indeed, if you go and count these, you'll find that it happened 79 times. So it actually did what we expected to do. All right. And here's, so after it's done, I checked the flag, the learn.stop flag, and it was false. So my question was, how did it get set to false? And the answer is that when it started validation, it set the stop flag to false. Okay, so then he goes on to refactor the callback class a bit more. And so we saw before that callback was a container for all of these different callback functions, but now we're going to refactor it. And it's going to become a container for a callback function that is passed in via the setRunner method, and you'll see that in here. SetRunner, this new method, you can actually set, you can actually give it a callback, pass it in this way. And the callback's name would be, in this case, would be run. Okay, so all this is just this. So the first thing here is this helper function. I'm not going to go through it too much, but because I'm not that familiar with regular expressions, but that's this regex, import RE, that's regular expressions. But what it's doing is it's taking in a camel case name. Remember, a camel case name of a looks like this. With a capital, it starts with capital letters, and every time you have a new word, you give it a capital letter. So that's one way to name variables. We don't usually use that, except for callbacks. And snake case is all lowercase and has dashes in between the words. So that's the difference between a camel case name and a snake case name. So by our convention, all the callback names are camel case. So what this does is it takes in a camel case name and converts it to this little helper function, takes in a camel case name and converts it to a snake case name. That's all it does. Okay. And why does it do that? Well, inside here, it actually makes sure that each callback has a name that corresponds to its camel case name. Sorry, its snake case name. So it takes the camel case name as an input, and it, by convention, which they didn't really tell you in Fast.ai, the callbacks have a suffix capital C callback. So we saw this thing before. We created this thing called test callback, and it was capital test, capital callback. Every callback name has a callback as a suffix. So what we're doing in here is we're going to extract, we're going to just erase that suffix, get rid of it, and then convert the remaining camel case string to a snake case string. So, and then there was this funny line here that says, return camel to snake name or callback. That was kind of weird. So I figured out that it's basically the same as this. It's going to try to do this, and if there was nothing, if there was no name, so then it would fail, and it would be an exception, and then you would just return the string callback. So that's what this thing does. If there's no name associated with this callback, then it can't do anything. It can't give it a name, so it just calls it its name string becomes callback. Okay, so let me, it's got this order parameter, which I'm not sure what it does, but we'll find out later, I guess. It has a set runner method, which allows you to give it a callback as an input. And then it has this get attribute method, which allows you to get its callback name. Okay, so that's all this. That's what this new callback class does. Let's see how that works now. So I wanted to show a little bit about how the new callback class works now. So I'm going to instantiate a callback object, C1 equals callback, and then I'm going to try, then I'm going to print its run attribute. And if there is none, then it will print the run as undefined. And that's what we expected to do, because we didn't give it a callback. We didn't give it an input. So we expect it to try to find the run attribute, and it won't find anything. In that case, it'll just tell us that run is undefined. Now, what if we pass we pass a callback function in? So we take the same object that we just created, C1, but now we use this set runner method, and we pass in a callback. We'll pass in that test callback that we created before. And now we'll ask, what is C1.run? And now we find out that it's got a name. So it's an object. So it's not a name. So it's basically this test callback object. But now we can ask for the name. See, check the get. What did I do? I made a note. Check the working of the get attribute method. I'm going to ask for the name of the after step callback, and I find it that it's test callback dot after step. So it looks for that. It looks for that after step callback in test callback, and it finds it, and it tells me that's what I got. Okay, here's an equivalent way to check the get attribute method. So I'm going to use this callback method underscore get attribute, and it actually does the same thing, because all the callbacks have, well, all classes have this get attribute method that you can use. So, but this is easier. I mean, you can just say get attribute. You can apply this get attribute method on the class C1 and looking for this after step callback. So this is just sort of how the callback works now. And then I wanted to show you an example of how this thing transforms a camel case string to a snake case string. So I'm going to just input this camel case string, ingenious new amazing trick, and see what it does to that string. The camel case string is ingenious new amazing trick, and the snake case name that we got by applying this function is, see what it does, exactly what we wanted it to do. It separates all the, everything, it lowercases everything, but at all the separators where it found capital letters, it now puts underscores. So that's the example of how camel to snake works. Camel to snake is just this black box function that takes as an input a camel case string and converts it to a snake case string. I hope that'll be clear. All right. So now we're going to refactor the test callback class. Remember, we created this test callback class above, and we're making it simpler now. All it does now is it has this after step method, and I put this I put this print statement just to help me figure out where we are in the processing, and it's just checking if the, let's see, if self.train, yeah, if the number of iterations is bigger than 10, is equal to 10, it's gonna return true, and otherwise it won't. If the number of iterations gets larger than 10, it returns false. That's all this thing does now. Now they're defining another class called train eval callback. Again, remember the name of callbacks by default has this capital callback suffix on it. And so does test callback. It has this capital callback suffix on it. And that's one of the actions that goes on inside of this new callback class is it strips off that, that's what it's doing here. It's substituting the string callback with nothing. That's what this is doing. It strips off the callback string first, then it returns the camel to snake name. That's what's going on there. Okay, so back to this new train eval callback class. We have begin fit method, we have an after batch method, we have a begin epic method, and we have a begin validate method. And what's going on in these methods, it's just, it's initializing the epic counter, the batch counter, and the iteration counter. And if we're in the training phase, so it says if not self in train, then return. So in other words, if self in train is false, then it's going to return. That means we don't. That means we're in evaluation mode. Otherwise, we set the we increment the epic number, and we increment the batch number. So this is what I was telling you about before. The total number of batches we saw for the training set was 700. I think it was 782, wasn't it? Back up here. I believe it was 782. Which means that every time we go through, yeah, it was 782 for the training set and 79 for the validation set. So, which means that every time we process a batch, we have processed 1 over 782 of an epic, right? And so then what it's doing is it's updating the epic counter. I'm scrolling back down to where, yeah, right here. So in this after batch method, after it finishes the batch, it then updates the epic counter by adding to it 1 over the number of batches, because it just processed 1 over 782 of an epic. Every time it processes a batch, it's just finished processing 1 over 782 of an epic. Does that make sense? So we're updating the epic counter, and you see why it's a floating, why it's n epic, which would normally indicate an integer, but I put float after it because it's keeping track of fractions of an epic as well. It's not just integers. Okay. All right, and then finally, the last things, begin epic, you would want to, every time you start an epic, you want to bring in that stuff that, I guess I don't need, yeah. In the run object, you're gonna bring in the epic.float and initialize it to whatever it was. So in other words, at the start of the first epic, sorry, when you finish the first epic, then this thing becomes 1. And then, so when you start the second epic, you're going to start from 1. You're going to start your count from 1, and then every time you process a batch, you're going to add 1 over 782 to that. Does that make sense? And then at begin epic, you're training. You never repeat epics when you're doing validation, right? There's no reason to. So when you're doing when you're starting an epic, you want to set the in training flag equals true. And then this is the begin validate. So it sets. So again, as the gentleman mentioned, I forget your name. You're the one that pointed it out. Here's where we turn on the validation flag. We tell the model that it's going to do validation, and then we tell that we set the in train flag to be false here. So that's what this train eval callback is. And then I just want to illustrate again this cog, the way that it calculates the callback name. So we've now we have the train eval callback. So now I'm going to pass in train eval callback name. I'm going to ask for the train eval callback's name. Remember, we went through all this rigmarole in the callback method to construct a snake case name for the callback. And so now I'm showing you how that works. So we now have a new callback called train eval callback. And because it inherits from callback, it's going to have this method it's going to have this method in a property it's going to have the methods that the callback has, and it's also going to have the property, the name property, which we saw. So when we ask for what is its name, it comes back and says, oh, its name is train eval. Because what we did was we took this string, remember, we took off the callback suffix, and then we passed it through camel to snake. We took train eval and converted it to the snake version of train eval. So that's how that function works. Okay, finally, almost finally, we have this runner class that he creates, and this is important for the future. I should mention that this 04 callback notebook showing how they use callbacks is going to be superseded later on in this class. I think it's in the 09 notebook, where they claim that they made it a lot easier to understand. So we'll see if that's the case. Anyway, you can see that this is pretty convoluted, the way they've done things here. And so this is, we haven't gotten through all the convolution yet. We have to get through this, this runner class. So first he creates this helper function. And all it does is it takes an input and converts it into a list. It's called listify. So anything, the input can be anything, and it converts it into a list. So if it, so anyway, that's what that listify function does. It's going to be useful later on. Now we want to look at this runner class. Oh, there's a lot of things in it, so I won't look at it all at once. So the first thing is it initializes itself, and it asks for two inputs that are optional. One of them is callbacks, and the other one is callback funcs. And I asked myself, why does it need two inputs? We'll see that later on, why. And I think what's going on is that the first input is callback classes, and the second input is if you just want to give a function, if you want to just give a callback as a function and it doesn't have its own class. So, so these things are lists, and they're optional, okay? So I made myself a question. It's not clear why we need two lists rather than one, but I think we'll see later on. I think I found out. So the first thing it does is it creates a list of callbacks from the first input, whatever this is. It takes this and makes it into a list using this listify function. And if there's a nothing there, then it just returns, if this is none, then it just returns nothing there. Callbacks becomes none. So that's fine. And then it goes through the second list. It runs through each of the functions in this list. And for each function, it gives it a callback name. So this set act function allows you to set a name, to give this callback a name property. That's what this callback name is. And then we and let's see, the set let's see, yeah, the set attribute function. Remember, it's from this let's see. I'm confused here for a sec. Callback.name gives me what? No? Well, I made a mistake. This is not the callbacks in this list are not simply functions. They're callbacks that, I think they're callbacks that can be called as functions, but they're still callbacks. So that's why the callback will have a name. So now we're going to, not sure why we had to do this. If the callback already had a name, I'm not sure why we have to give it one. Anyway, let's just skip this. But then what it does is it appends this callback to the list that we originally built. So it's going to go through if there's both lists, it's going to concatenate both of these lists into a single list. And that's here. Okay, then it sets a stop flag, which would be the run. Self.stop means run. You know, if you ask for the flag, it would be run.stop, because this thing is going to, well, this thing is usually called, when you instantiate a runner class, you usually call it run. We'll see later. And so then its stop property would be gotten at, you'd get at it by run.stop. Okay, so you initialize that to false, and the callback list that you give it is the call. Okay, so it does this. So first it goes through and processes these two lists of callbacks and makes a single list out of it. And then it appends this train eval callback to that list. That's what it's doing here. So we built this train eval callback, and now we're giving it to the runner class as a method to use in the future. And then it gets the properties from the learner objects so that it can use them. So it gets it's got from the learner object that was passed in, it gets the optimizer, it gets the model, it gets the loss function, and it gets the data. That's what's going on here. And then here's this method to process a single batch that we've already seen. It's basically being incorporated into this runner class. And then here's the method to process all the batches. We've already seen this. It's also being incorporated into this runner class. And here's the method to process the training and validation sets, which is the fit method. We've seen that. And so we can see what it's doing here. It's going through and trying. It's got a try block. So it tries to loop over all the callbacks in the list and does the set runner for each one, does that set runner function for each one, which gives it a name. And let's see, if it's begin fit, it returns, and then it processes for each epoch. It processes all the batches if we're in training mode. Then it checks to see if we're in validation mode. And if we are, then it processes all the batches in the validation mode, which means that it's not doing it's not doing the backpropagation step. And then it breaks if after epoch is set true. And then finally, it sets the after fit state to true. And then it erases the learner object, which is kind of weird. I'm not sure why it does that, but that's what it does. And then, so then it has this extra property, extra method that it gets added to it. And this is what this does. This dunder call method allows you to call that as it allows you to call this thing as a function. So instead of having to instantiate the runner object, you can actually call it as a function. And then, and what it does is it loops through all the callbacks in the list, and it sorts them in order. That's what this order thing is doing. I'm not sure exactly how it gets used, but remember, it has this order parameter, and it sorts them by the order parameter. And for each one, it gets the callback's name, and then it checks to see if the callback is there. So if you ask for the callback's name and it didn't have a name, then it would come back with none. And so F would be none. And then this next thing would be if F and F would just give you none. So, but if the callback had a name and it was also truly a function, then it would return true. So it's checking to see whether not only the callback has a name, but that it's actually a function. And if it is, then it returns true. Otherwise, it returns false. We're running out of time. There's another callback that it creates to compute the loss metrics and the loss and the accuracy metric. That's this one. It's pretty straightforward. And so we can add that method to we can add that callback. And then we instantiate the average stats callback to compute accuracy. That's what this stats thing is. Oops, I didn't run it. I think that's what it's complaining about. I didn't. I got to do this. And I got to do this. And okay, so now we've instantiated that callback. Now we instantiate the runner object. Remember, now that we have this dunder call method, you can actually call it as a function, and that's what we've done here. We instantiate the learner object that is that we need in order to process the batch, and now we can run the training loop by this method, run.fit, and it does it. And then we've only asked for 2 epochs, so it's done. First, it does the training, then it does the validation for each epoch. Then computes the stats. That's what this stats does. Computes the loss and the accuracy. So this is the loss function, and this is the accuracy. Okay, so that's this is how you can use this is one way of doing training. And notice that the input was a callback. Now the second way is to use the callback funcs input. So the first way is to use the callbacks input. Remember this thing, the runner class takes these 2 inputs, callbacks and callback funcs, optional. So this is what happens. This is how another way you can call it. Construct a callback function that does the same job as stats. That is just going to be a function. So we use this partial function to do that. It takes the input as a class. It takes the input, this class, and it gives it the accuracy as an input, and now it becomes a function. So now we instantiate the runner object using a callback func instead of a callback. And we do the same things before, get the learner, run the fit, and get the statistics. So this is just the 2 ways to that you can call the runner, because it's got this weird optional input, 2 different optional inputs. Okay, I don't have time to get through the 5th one, but it's pretty straightforward now that you've seen. It's basically just going a little further and defining a few more callbacks, an early stopping callback, and then it defines this learning rate finder callback, which is something you've seen before in the first class, that allows you to monitor the learning rate. And so that's what this does. I didn't have time to get through it. So next time we'll go through the 06 notebook and the 07 notebook, and then we'll finally be done with chapter 10. But meanwhile, you should run through this 04 callback and make sure that you understand at least as much as you can about it, and then run through the 05B early stopping notebook. And for next time. And then if you have time, go through the 06 and 07, but I'm going to refactor them a little bit to help us understand them before we talk about them next week. All right, so that's all I have to say. Are there any questions up till here? All right, well, thank you for your attention, and we'll see you next week. I'm going to stop now. I think I still have to stop in order that they can start the 224 class. So I think I'll stop. Okay? Bye, everyone.